Let's begin. Today's June 18th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses 5 criteria cards and it's 5 verification cards. Let's go to turingmachine.info for the details. So today's puzzle uses the following 5 criteria cards. Criteria card 2, 8, 14, 16, and 21. And they use the orange verification cards. The code above is your way to get more information on today's puzzle by going to turingmachine.info, typing in this code, and searching for the puzzle. Let's solve. So in our grid above, we've got our 5 criteria cards. On the top row, we got criteria card A, criteria card B, criteria card C. In the bottom row, we've got criteria card D and criteria card E. So criteria card A looks at the first digit, the triangle digit, and compares its value to the number 3. So should the value of triangle be less than 3? Should it be equal to 3? Or should it be greater than 3? Criteria card B looks at our 3-digit solution and will let us know how many of those digits are 1. Are there no ones? Is there a single one? Perhaps there's 2, maybe even all 3 are 1s. Criteria card C, again, looks at our 3 digits, our triangle, square, and circle, and will let us know which one is the absolute smallest. Should triangle be the smallest? Should square be the smallest? Or perhaps it's circle that should be the smallest. Criteria card D, again, looks at our 3 digits in our solution and will let us know something about the ratio of even to odds. So should there be more even than odds, or should there be less even than odds? And finally, criteria card E will let us know a little bit about the structure of our code, and so much so that it will let us know whether there should be a pair of digits, repeating digits, as in the example 131, or alternatively, there are no pairs, and there are a couple scenarios. Either they're all different, as in the example 134, or they're all the same, such as the example of 222, a single digit repeated 3 times. Remember, our objective is to find this unique 3-digit code that abides by all the criteria cards we just discussed. And we're going to start off with our proposal of 314. So the first thing I want to test is I want to know how many even to odds there are. So I'm going to test criteria card D. Okay, so the Turing machine responds that it does not approve of my proposal. Notice that in my proposal of 314, I've got 2 odds to a single even. So the Turing machine does not agree with that. So what it's telling me is that, in fact, there should be more even than odds. So I'm going to write that up in my notes section for D. So I'm going to type in even is greater than odd. And at this point, we don't know. At a minimum, we do know that there should be 2 evens, but potentially there could be 3 evens. Okay, so let's see what criteria card E will let us know. Again, it'll basically respond whether there's a pair or not. So let's go ahead and test criteria card E. Okay, so again, it does not approve. Notice that in my proposal 314, I have all unique digits. So basically it's a no pair, but it's telling me that that's not true. So in fact, there is a pair of digits. So let me go ahead and type that up in section E, that there is a pair. Okay, so we know that the pair must be even because we already know that there's more even than odds. So, and I'll just say, and it's even. And, but we don't know about anything about that the 3rd digit. It could be either an even or an odd. We just don't know yet. And at this point, we really can't eliminate or cross out anything. So we're left with basically all the criteria cards on top. We're comparing the triangle digit. I do have a 3. Well, actually, okay, so this is an interesting point. Notice that the criteria card B will test if there is how many ones there are. Well, at this point, since there's only one potential odd, well, let's see. Okay, so we know that there can be 3 ones or even 2 ones. The fact that and I do have a 1, so if it comes up with a check mark, then fantastic. We know the odd is 1, or there is an odd and it's 1. But if it fails, it doesn't really tell me whether there's still an odd or not. It's not a 1. Let's see. So it's not that it's a 50-50, but I do have that 1. And we would know that the smallest is a 1 because, there is an absolute smallest. Is it worth the risk? I think, well, let's see. Let's think about this. We do have a pair of evens, so it's either 2-2 or 4-4. If there is no 1, well, it could be, a pair of evens and the other even. I wonder, is there, well, okay, yeah, it can't be a triple digit. So, yeah, let me go ahead and test criteria card B, and let's see what happens. Okay, so yes, there is no single 1, but that still does not tell us anything about that even. Okay, so we just know that there is no single 1, or there is no 1. There is no 1 digit. Well, I guess in some sense that is also helpful, since we know that there isn't a 1. We can cross all of them out. So we know that the smallest is not 1. So at least that's something. Okay, so let's yeah. Okay, so there is no 1. All right. So there still could be an odd. Now, okay, so this is interesting, because we know we have a pair of evens. We also know that there can't be any 5s, right? Because if 5 is the only odd, the pair of evens, there is no absolute smallest if the smaller of the single digit and the double digit is at the smaller is a double digit, and so it can't be a 5 either. What an interesting not coincidence, but kind of conclusion. So yeah, very interesting. If there's no 1, there can't be a 5 either because of the pair of evens. Okay. Well, that's a little helpful now, because now we've kind of limited to either a pair of 2s or a pair of 4s, and the other digit must be either a 3 or a 2. So let's think about this. So again, we just concluded our first round, and so now we're going into the phase where we're thinking about how to construct a good second round proposal. And so the only thing that we did not test was criteria card A, which compares the triangle digit, and C, which is the absolute smallest. So let's see, could 2 be the absolute smallest? Yeah, 2 could be the smallest, and then we have a pair of 4s. That's possible. And I believe that would be the only scenario where if 2 is the smallest, then it'd be a pair of 4s. If 3 is the smallest, then we also know there's a pair of 4s. Okay, well, wow, very interesting. So we can't have, actually the pair of evens can't be 2. Again, because of the same reason why I crossed out the 5s. You can't have a pair of 2s. The 2 is not the smallest, can't be the smallest. It's paired up. So we know that the pair has to be 4s, and now the smallest is either 2 or 3. Wow, very interesting. Okay. So we're looking at a pair of 4s. So let's see, are there just too many to list out? I guess technically, how many ways are there to pair up 4s? I think there are 3 ways to pair up 4s. And then the smallest, I guess there's 3 ways to pick the 2 or 3, so there will be a total of 9. That's too many to list. So let's see, what can we, well, let's see. If triangle is greater than 3, that'll be one of the paired up digits, paired up 4s, which is possible. So if this is a 4, is there any? Yeah, so basically square or circle will be the smallest. But which one would it be? Would it be 2 or 3? There's no, yeah, so I don't think triangle can be 4, because then how would you, let's see. Yeah, both 2 and 3 are smaller, so it could be either or. Well, let's see, is that right? Right, well, okay, so this will tell me which is the smallest, square or circle. But is it 2 or 3? Yeah, that's the question. Is it 2 or 3? And so, yeah, so I don't think triangle can be 4. So I'm wondering, should I cross? Okay, oh wow. Oh wow. Yeah, since triangle can't be 4, and let me see the logic sound. If triangle cannot be 4, because even though we know square or circle to be the smallest, well, you could either pick 2 or 3. Yeah, they both would be the smallest. Yeah, because there's nothing clear cut about which one it should be. Yeah, so basically, I think square and circle have to be the pair of 4s. So let me go ahead and cross out this 4 here. And so that means I just need to figure out whether triangle is 2 or 3. And that's a 50-50. Okay, so let's see which, remember all the cards cannot be, oh, this is interesting. So we still have to pick a smallest. Oh, wow. We still have to pick a smallest as well as this. So that's interesting. How then what does it mean? Which one do you pick? I don't think it's going to be a 3, because if I knew triangle were 3, then of course it would be pair of 4s. Is that right? Could it be 2, 4, 4? Okay, I'm just going to go ahead and test that out. So let's go with 2, 4, 4. And I'm going to test criteria card A, since I know it's already the smallest. But that just doesn't seem, okay, well, let's just go for it. All right, so let's do criteria card A. Okay, so it is, in fact, triangle is less than 3. So let's go ahead and put that down. So triangle is less than 3, and of course then that means it's a 2. So we still did cross out the 4. So I think that's a little bit, additional justification. And we knew that there weren't any 1s. So yeah, it's a 2, and then it's got to be 4, 4, because you got more evens and odds. Okay. Well, let's see. Yeah, let me go ahead and cross out the 2, or actually, let me do this. Well, yeah. Cross out the 2, and then cross out the 3. And so, yeah, we've got our pair of 4s. And then same thing here. Cross out the 2. Cross out the 3. All right, so I'm saying that the answer should be 2, 4, 4. Okay, so let's see. We did confirm that triangle has to be less than 3. So it's either between 1 and 2. And of course, there were no 1. So yeah, 2 makes sense. And because technically 2 could not be paired up, it would have to be 4. Yeah. Wow. Okay. This is very interesting. So I didn't have to test C. Well, let's go check. 2, 4, 4, if that's our solution. So test 2, 2, 4, 4, and let's verify. Fantastic. Okay, so let's go to see if we beat the Turing machine. So first round, B, D, E, all wrong, and then a single correct one for A. We did not do C. So B, D, E. So B, D, and E. And then in the second round, we did A. And I feel confident that we should beat it because we did less tests than there are Turing cards or criteria cards. Well, there you go. So we answered it in 4 questions, and the Turing machine took 6. So some great observations. Yeah, I guess it paid off to test criteria card B because that really, it crossed out all the 1s, and then also thinking about 5 being canceled, using a little deduction, knowing that any pair of evens smaller than 5 could not be the smallest. So that was very helpful. So some of that deduction and just talking through the possibilities really did help us answer in less than the number of criteria cards. Well, this was a great solve. I really do enjoy, thinking through some of these interesting scenarios with the Turing machine puzzles. Well, if you enjoyed the video, please do give it a thumbs up. If you notice anything interesting that you'd like to share, please do put it in a comment. And if you don't want to miss out on any future videos, please hit subscribe to be notified. Well, until next time, have a great one.